A very good evening to all. Today, I, Isha Goyal, on behalf of CSIR CSIU Jigyasa team, welcome you all to the Bootcamp on Energy being organized under Jigyasa Vigyan Mahotsav. It's a matter of pleasure for all of us to have Professor S. Anantha Ramakrishna, Director CSIO, and Professor Vijay Mohan Pillai, ICER Tirupati, as invited speaker for our today's event. Welcome you all, sir. Jigyasa is one of the major initiatives taken up by CSIR at national level during its Platinum Jubilee celebration year. On one hand, this program would explain the culture of curiosity and scientific nature, and on the another, CSIR at national level is further widening and deepening its scientific social responsibility through Jigyasa program. Jigyasa programs are designed to connect school students with the experienced scientists with an objective, learning science by doing science. Under this program, we arrange various activities for school students to enhance their scientific approach. As a part of Azadi Ka Amrit Mahotsav, India is commemorating 75 years of independence. The Ministry of Science and Technology is hosting the Amrit Mahotsav Science Showcase Roadmap to 2047 celebration as a part of this. CSIR, under the Ministry of Science and Technology, is organizing a national level scientific creativity competition, Jigyasa Vigyan Mahotsav 2022. Today, we CSIR CSIO Jigyasa team announce our tremendous happiness to host the Bootcamp1 under the theme Energy for Jigyasa Vigyan Mahotsav 2022. To formally inaugurate the today's event, I would like to invite Professor S. Anantha Ramakrishna, Director CSIR CSIO, to deliver the welcome address and give his opening remarks. Over to you, sir.
Thank you, Isha, very much for the wonderful introduction to the program. And I think this is a wonderful moment when the Jigyasa team at CSIO has decided to come forward and talk about energy. Energy, today's program, which is all about energy. The theme is energy, and we all should be energetic, of course. But then I'd like to, in the same breath, energetically welcome all of you. Welcome the speaker, Professor Vijay Mohan from ICER Tirupati. And the thing I would really like to convey to you is energy is probably the reason for everything in the universe, including all of human life, including the very existence of our present state of the earth. This thing that we learn while in school, energy as displacement, work done, or which is equal to the force times the displacement for a mechanical object. This idea is generalized to so many contexts. And eventually, when Einstein wrote E equal to mc square, thereby relating all mass to energy and the energy content in mass, or the energy defect as we would know in nuclear physics, it kind of completed the entire circle. Matter and energy became, you could not differentiate between them anymore. Matter was energy, energy also was matter. So when we think about it and go ahead and we look at what is this energy that has created life around us, we find that it's all the energy that's actually emitted by the sun in our local context. And this energy by the sun is what keeps everything alive around us, whether it is the atmosphere, whether it is the environmental conditions, whether it is the forests, the trees and everything. All the energy has actually come from the sun, almost all of it. very minuscule amount from maybe interstellar sources, but everything is mostly from the sun. And this energy, life-giving energy, is what we have thrived on. And today, if you just look at it, not only are we now trying to use this energy indirectly, the way you have traditionally done through plant life, we have derived this energy through other means, we have derived this energy. Today, a large quantity of energy is directly being harvested from the sun as the solar energy. And that energy amount in our Indian national context, where we have gone in for solar photovoltaic energy on a very major level, it's just amazing. The amount of energy in the quantum of light in each little bit is so small, 10 power minus 19. But together, when there are so many photons that come from the sun and which is harvested by us in our solar panels, we ended up with huge amounts of energy. Energy in one photon is 10 power minus 19 joules. But we are actually talking about megawatts, easily gigawatts of power. So we are talking about something like utilizing 10 power 28, 10 power 30 photons per second. That's the kind of things, or even much more than that. That's what we are today talking about. So it's a simply amazing thing what has happened in energy. These kind of numbers typically you find when people are talking about what is the distance between galaxies or what is the lifetime of the universe and things like that. But today we are having them even in energy. What's the number of photons that drives a gigawatt power station? So, I just keep wondering at this energy. People have found so many new ways, and I'm sure our speaker would, tell you a lot more things about it. And we have the quiz, I think, after that. So, I think we can look forward to some intellectual treats today. We are all going to enjoy today, just having fun about energy. So I welcome you all to this energetic feast, and I hope that we'll have a good time together. And I thank the team Jigyasa wonderfully, Dr. Pooja Devi and Dr. Nirja Mittal, who are also here, for wonderfully putting together this program together. Thank you.
Thank you so much, sir. Thank you so much for explaining energy, the concept of energy in such a simplified way. Thank you so much for your remarks. Now moving ahead, I would like to invite Dr. Nirja Garg, Senior Scientist, CSIR, CSIO, Chandigarh, and Nodal Jigyasa, to give a brief introduction about Jigyasa Virtual Lab of CSIR. Over to you, ma'am.
Okay, thank you, Isha. Am I audible?
Yes,
okay.
ma'am.
So good evening, all. Firstly, I would like to share my screen to show the presentation. The Jigyasa program was started in year 2017, and this program aims, it refers to Scientist-Student Connect program, and it aims to opening up the national scientific facilities to school students, enabling CSIR scientific knowledge and facilities to be utilized by school students. The major activities those we are covering under this program are laboratory visits. There are popular lecture science series, summer vacation programs are there, scientific and teachers as scientists program is there. One interesting part of this program is the teachers workshop, student residential program is there. Visit of scientists to school, means where the scientists visit schools and they impart their knowledge, they work with students in their laboratories and guide them. There are some lab specific activities. Now going towards the Jigyasa virtual program. Now, as we all know about the current pandemic situation. From last 2-3 years, the students and scientists, they are not able to connect properly. There are no physical interactions and communications between the students and scientists. In order to avoid this, the Honorable Prime Minister encouraged the development of virtual lab so that the science can further be taken to students and throughout all the corners of the country. A concept note was prepared and task force committee was set up by CSIR Director General. Research surveys were carried out, a lot of meetings were going on between CSIR and CL on the basis of the NEP and STIP policies. In 2020, 4 to 6 months pilot mode of virtual laboratory was implemented, wherein some of the activities were developed by the CSIR labs. And in order to create a knowledge pool generated by scientists and science communicators between this, by using the knowledge of students and teachers, IIT CSIR has partnered with IIT Bombay to develop a virtual lab platform, and a MOU was signed between CSIR NCL and IIT Bombay to facilitate classroom learning with laboratory research. The target audience for this program is 6th to 12th standard students. Herein, we are developing computer simulated programs in the form of videos, games, comics on the topics of physics, chemistry, mathematics, and biology. Environment-friendly 3D modeling concept is used in this. A dedicated and interactive online Jigyasa portal has been launched by the Honorable Minister, Science and Technology Minister, Jitendra Kumarji. And this particular program is available online to be used by the school students free of cost. And it may be used in online and virtual and offline mode. This is a screenshot referring to that the activities developed by CSIO during this pilot mode. We have developed some science games, simulation programs have been implemented, stories and comics are developed, and 4 videos are developed to impart the knowledge to school students. The aim of this virtual lab is to provide quality research exposure and innovative content to school students so as to drive scientific curiosity based on their interactive medium with simulated experiments and videos. I would like to showcase the hosted website where all these programs have been shown so that you will be able to understand how these programs and activities are working in online mode. There is the web hosting link, that is jigyasa.csir.in. These are some of the activities those we are developing during this year. Now, there are the glimpses of the activities. This is the front page of the website. The screenshot is not there. Okay. Only presentation is coming. Okay. So let me remove the presentation first. Stop screen कर दीजिए.
Dr. Nircha, maybe I can take over the website part. Is it visible? Yeah. Okay.
Okay. These are the activities. Those are being shown on the virtual platform. Actually, earlier I was not able to screen share. Now the screen is visible, I think. So these are the kind of activities: comics, infographics, interactives, games. While moving towards the games part, on the left hand of this website, we are having objective, then the science behind this particular game, as this is a color game, and here student must be able to understand the difference between primary, secondary and tertiary colors. In order, when the student want to play this game, so they have to start, there will be some instruction page. After that, on clicking on play, there will be a question, which color is this? On getting a correct answer, the student will be able to perform we will be able to fill in the color which is associated to this. Here the operating instructions are given. One more interesting game that I would like to show is the periodic table game. In this particular game, it is developed in a form that student will be able to learn about the atomic number, atomic mass, and their properties of this atomic table. Every +1, +2 students have to learn these periodic tables to work in chemistry, to perform in their competitive examinations. So this particular game is devised to help them to learn all the elements and their properties in a fun manner. While playing this particular game, they will be able to learn about, and they will be able to learn the atomic number, weight, and other characteristics. They are the instructions where we have shown how to play this game. First level game is the dice slave. On playing the dice, when 6 comes, the student will be able to start, and as per the number, the dice will stop at one particular location, and a student will be displayed with one question where he or she will be able to learn about the atomic number and mass. There, initially we have developed 2 levels. In the second level, you have to enter the name of the players. In this, the student will be able to place the elements. The elements will be displayed here in the form of a question. The element is telling about itself that I am lead and my atomic mass is 82. The student have to place this dite at its appropriate place within the table. In this manner, the student will be able to learn about the placement of atomic elements, and thereafter a question will appear on its characteristics. Briefly, we have described about the objective, science behind this particular game, significance and description of this game, how to play this. These are the simulation experiments. It is only the glimpse of one of the experiment. In order to find out the numerical aperture, we will be able to change the laser angle, distance from the screen, and then accordingly the value of refraction angle from the medium will be displayed here. One more, only the last activity that I would like to show is the comics part. The objective of this particular comics is to understand about atoms, and light reflection. Science behind this particular is already given here, significance, description. In this particular comics, the students will be able to learn about the atoms and its characteristics. We know that the students are nowadays all the students are at home and they will be able to read these comics and will be able to understand the science. So this is the main objective of this virtual laboratory, that the students will not be limited to learning while they are at home. So the 2 kinds of content we have developed. One is related to their academic curriculum, wherein we have tried to cover their physics, chemistry, biology part. And second type of content is related to latest developments. Those are designed within the labs by the scientists. So in this way, we are imparting the students with their academic curriculum related knowledge. In addition to, they will be aware with the latest developments, those are going on within the CSIR labs. And they will be able to interact with the scientists. They will be able to clear their doubts by interacting with the scientists through their webinars, through chat forms. Chatbots will be designed. And this is all about the virtual laboratory. Now I would like to hand over the mic to Isha for the next. Thank you for listening.
Thank you, Nita ma'am, for enlightening this prestigious platform to all the students. Thank you so much. Now, taking the event forward, I would like to invite Dr. Pooja Devi, Principal Scientist, CSIR, CSIO, and Coordinator, Energy Comics team, to narrate about the Jigyasa Vigyan Mahotsav 2022 competition.
Thank you, Isha. I would first request Dr. Nirja to unshare the screen. So, welcome all the participants, all the students, and welcome to Professor Vijay Mohan Pillai for agreeing to deliver the popular science lecture on the theme of energy. As Dr. Nirja already informed all the participants about Jigyasa virtual lab. So, and she has also made you all aware about kind of content which is being developed under virtual lab that includes comics, different kind of simulation games, or different kind of stories. So this, on the basis of that, a national level competition is being organized by CSIR. So I will make all the students, participants aware about this competition, its guideline, and I will not take much time before we listen to Professor Pillai for his popular talk. Dr. Nirja, can you please unshare your screen so that I can share the instructions? Yes, thank you. So I hope my screen is visible. So this national level competition, which is under Azadi Ka Amrit Mahotsav, being celebrated by CSIR. So this competition invite the students to develop the content in the field of science. So it is basically helping the students to utilize their creativity, their artistic part in the field of science. So we invite the students to develop the content in form of different categories as shown by Dr. Nirja. And the selected winners from this competition will get an opportunity to showcase their content at a national level virtual lab platform, which is just shown just a few minutes back. And there is also other attractive prizes for the winners. I would like to inform that this competition is being organized under different themes, which include energy, health, artificial intelligence, disaster mitigation, water conservation, climate change, and agrotechnology. So today we are having in the form of like videos, comics, app development, or animation, or maybe in the form of infographic. So you can develop the content either in Hindi language or English language. So there is no language barrier as such. And you can make the content either by hand-drawn or a digital mode. So both mode are welcome. In the content, now you may think, what should I develop in the content? So under these different domains, which I just mentioned a few seconds back, you can either identify some issue, you can create any awareness about any topic related to you can give some solution to the problem which you see around you, and you think that by some solution you can propose, or you can also give some futuristic or maybe crazy idea or out of box ideas. So it's up to you what you want to develop in your content, but for sure it has to be related with the science. And how we will evaluate the children for their content? It will be mainly evaluated in terms of their creativity, their ideas, what is their storytelling capability, and how well they are conveying the message. And like in case of apps, videos, and animation, the usability of such content, which is to be developed by you people. So these will be different criteria which will be used to select the winners under different categories. I would also like to mention some terms and conditions associated with this competition. This competition is open for the student from 8th class to 12th class. The medium can be either Hindi or English. Student can participate as a like individually or in a team of 2 to 5. The final prize will go to the team, and the certificate will be given to all the team members. And one important thing in the kind of content you are developing and you are submitting, it must be taken care. There should not be any plagiarism, or there should not be any infringement of copyright, and it should not be copied from somewhere else. It should be your original ideas. So you have to take care of these basic things. And depending upon your will, you can participate in either one content type competition or more than one. So these are certain things which you have to take care while submitting the content. All these terms and conditions are also given onto the website of Jigyasa Virtual Lab, which you can go through. Now, as a part of this competition, to make the students aware about different themes under which this competition is organized, we are conducting boot camps. So in Bootcamp1, today's session is under Bootcamp1. The students will be made aware largely about the topic, about the theme, and they can interact with the speakers with their queries. And at the end of the lecture, there will also be a quiz. So students who are participating in the bootcamp to this lecture through Zoom platform, as well as since it is being live streamed on CSR Jigyasa YouTube channel, through YouTube, they have to take this quiz. And the students who qualify the quiz, who participate in the quiz will get the certificate of participation. And after this theme level bootcamp, there will be another bootcamp where the students will be given exposure about different kind of tools, different kind of ways, and to develop comic videos, infographics, science fiction, apps, and animation. So this bootcamp will be organized next week, and this week we are conducting bootcamp under different themes. And today we are, so you can see these are the different kind of timelines for different boot camps. In the morning, we also, in the afternoon session around 2 p.m., we had a first boot camp on the theme of health, as well as inauguration of this competition. And now CSIO is conducting this boot camp in the theme of energy. So today we have with us Professor Vijay Mohan Pillai, who is very well known expert who has worked a lot in the field of energy as our invited speaker, as a popular science speaker, to speak about energy theme, to give you an idea about this particular domain. So I urge all the students to listen to him carefully, and also there will be an interaction session with him. Followed to it, a quiz will also be conducted. And this is a YouTube platform. All the boot camps which we are conducting, all these webinars are also being live streamed onto CSR Jigyasa YouTube channel. So in case if you have missed today's session, you still can watch the session onto YouTube platform, and you can get information, knowledge about this energy domain, and then you can plan your ideas to participate in the competition finally. And Dr. Nisha already made you aware about Jigyasa Virtual Lab website. So this is the website, how it looks like, and you can explore different kind of content which are placed over there. So these are content developed by scientists of different CSR laboratories, and there you can see there's a lot of creativity inbuilt along with the science. So you can also have a glimpse of how different kind of contents are there and get an idea about your topic as well. So I now also request all the participants who are watching us onto YouTube and have not yet registered. I request all of them to register for this competition through this Jigyasa Virtual Lab websites. They can register from there directly. And I will now end it, but by requesting all of you who are with us to follow us onto our different kind of social media platform, and also visit Jigyasa Virtual Lab website for the regular updates on different boot camps and also different competitions announcements. So this is all from my side. With this instruction about this national level competition, I now hand over to Isha to take the proceeding further. Thank you.
Thank you so much, ma'am, for giving detailed information about the competition. Without further delay, I take this opportunity to introduce our today's speaker, Professor Vijay Mohan K. Pillai, FNA, Fellow of Academy of Sciences, Chemistry, and Dean, Indian Institute of Science and Education and Research, Tirupati. Dr. Vijay Mohan K. Pillai is a leading electrochemist from India. He received his PhD from the Indian Institute of Science, Bangalore. He has authored over 220 publications and 20 patents related to many innovations in both electrochemistry and material chemistry. With an experience of 20 years in materials electrochemistry, fuel cells, catalyst materials, batteries, and ultracapacitors, he is a recipient of many prestigious awards, including medals of MRSI and CRSI. He is a fellow of the Indian Academy of Sciences and affiliate members of IUPAC. He is also in the editorial boards of several prestigious journals. As a healthman at CSIR, CECRI, Dr. Pillai strives to make the institution an internationally renowned place for electrochemistry. With this, I would like to call our esteemed guest speaker, Dr. Vijay Mohan K. Pillai. Over to you, sir.
Thank you. Good evening. Thank you, Isha. I hope I am audible.
Yes, sir.
Okay, good. Let me first thank Professor Ananda Ramakrishnan and Dr. Pooja for inviting me to share my thoughts on renewable energy or clean energy with all of you young children. It is a great privilege because you are all the people who is our future, and energy is very important for our future. So I am also delighted because CSIO Chandigarh is doing wonderful things, making comics and many platforms for children to assimilate these ideas in a very, very easy manner. So let me appreciate all the laudable work done by the scientists, especially Neeraj, Pooja, under the guidance of Professor Ramakrishna. What I would do is, I would just give you what is happening in our country in the area of energy without going to very complex terms. I am sure that I would talk to you in a very simple language. I already see that you are all, gifted children. See a lot of questions. What is the limit of energy? Whether it is theoretical limit, experimental limit. We can calculate limit using cosmological constants, but those are all very, very involved processes. So let me talk to you in very simple terms. What is energy? How we generate energy? What happens when we generate energy? Some untoward incidents. Bad things happen to our environment. How do we minimize it? And how nanotechnology helps you to make new materials, wonderful materials, which in future at least we hope we will be able to make energy without any problems. And we will also stretch our imagination. Future, we can even make suns, mini sun, micro sun. So much of advancement happens in science, in the area of fusion. So I would give you a cursory glance of what is the present status, why we want to make renewable energy, what would happen if you continue to make energy in the way we have been doing. So this is what is our plan. Of course, in the end, I would answer as much questions as possible in the chat box. So please don't worry. Whatever questions you have, doesn't matter which area, keep on putting it on the chat box. With this, let me see whether I can share my screen. Dr. Pooja, is it possible to see my screen?
Yes, sir. Kindly make it full screen, sir.
Yeah, I'll make it full screen. Is it okay?
Sir.
Yeah. Anyway, it's a pleasure because I see around 81 participants, and I'm quite delighted by the large number of participants. Yeah. So I think CSR, Vigyan, Mahotsav, energy is a major theme because energy is a perennial problem for us. Our country, like India, we are growing every day, every week, every month. Although problems like a pandemic come and disrupt our activities, still we have problems. And we have some ways of making energy. We are doing energy, we are generating a lot of energy. Our average energy consumption per day, that is very important, called per capita number. This number will tell you how good life we have. For example, US per capita is much more. Europe, again, maybe 20 times more. So India, the per capita energy, that means per energy consumed by one person in one day, is very small. That's the reason why we are still not a developed country. However, we want to grow, we need to generate much more energy. The problem is when we generate energy, we have a lot of carbon dioxide emission, many other things which we generate, unwanted things. They create problems, global warming, sometimes you have drought, sometimes you have flood. So these unanticipated climatic problems, all these we need to stop it. That's why we need to make energy in a particular manner, a clean energy. We want to generate energy, but it must be clean. What do we mean by clean energy? Are there methods to generate clean energy? How do we store this energy? How do we transform this energy? All these questions we will be talking today. We will focus more on energy from renewables, not from fossil fuels. Renewable means solar, wind. Some of you are already familiar. You have seen in your school, there may be a small solar panel. You must have seen a windmill while traveling in many parts of our country. So what is special about these methods of generating energy? And more importantly, we need energy for so many purposes. Sometimes small energy, sometimes large energy. I will talk to you about all this energy. How do we store it? And then what are the problems we face? And in future, what are the major things available for us? We have wonderful materials. Some of these materials can store energy for a long time without any loss. Some of these materials can allow you to have a car with no environmental emission. We talk about electric vehicle. We are going to have a huge revolution in the way of transportation in our country. High flying cars. So we look at future. We predict some of these developments. This is what is the plan today. I'm sure all of you know the importance of energy. I'm sure the director of CSIR just mentioned about it. Evening, if you don't take snacks, you have a problem. If you don't eat one day dinner, energy is less for you. You cannot run around in the morning. You will have your energy level is very low. So when you eat food, it gets oxidized in the body, and you get eventually hydrocarbons are formed. Glucose is generated. They are stored in the body. All this is very important. So energy is a fundamental factor for a good living. All of us, if you tell me how much energy you use per day, I can tell you what type of life you have. Imagine morning you get up by an alarm. Most of us get up by an alarm. Alarm means what? There is a battery. Battery is something stores energy. Without the battery is not working, someday the alarm doesn't work and you say, oh, battery is gone. I need to change the battery. So your life starts with energy stored. Then you take up, you go to the bathroom, you want to take water, or you want to have hot water. Another way of spending energy. So please remember, the moment you get up on the bed, when you hit the bed in the night, in between, how many times you are coming across different modes of energy, various forms of energy. That's why energy is something very important. Now, if you look at the humanity, we have several challenges for next, let's say, 50 years. Most of these are linked with availability of energy and also availability of materials. So energy comes as number one challenge for humanity. We have plenty of energy, development becomes very easy. For transportation we need, for manufacturing drugs we need, for COVID detection we need, even for making these COVID masks, we need energy. Please remember that every aspect we need different forms of energy. Without energy, it is impossible for anybody to survive. How do we make this energy? There are various ways of making this energy. So if you see all the global problems, energy comes as number one. Perennial problem of generating energy without any problems for the environment. Water is another major problem. But if you have plenty of energy, water problem can be solved. You can take seawater, purify, reverse osmosis, any methods, and then you will get water. Similarly, food. If you have plenty of energy, then you can always create food, generate food. This is why all other problems also could be solved with energy. Environmental problems can always be solved if you have plenty of energy. So please remember that energy is a fundamental issue. What happened is, last few years, our life is disrupted by pandemic. That is why you are seeing this globe, globe is almost damaged partly. This is partly because of the pandemic. So even to fight with the pandemic, we need to have energy. Planet Earth is closed for repair, but repair needs so much of energy. The way we have been making energy traditionally, there were a lot of problems. How do we make energy? We have got coal, we have been using fossil fuel. Fossil fuel is not good for environment. You have a lot of gases coming out, most of you are familiar. At the same time, the pandemic, we have been talking about pandemic disrupting our way of life. Like, otherwise you would have been meeting in a physical room. Now it is very difficult. Traveling is a problem, to vaccine certificate, all that is. However, pandemic has also given some good things to us. Number one is that you can imagine pandemic situation. Before starting the pandemic, all these flights were there. Every flight generates so much of CO2. Please remember. Now the number of flights have come down. Similarly, the water pollution, there are many cities in China and Europe, just because of pandemic, there was a lockdown, and then the air quality and water quality, there is a significant improvement. All this shows that, look, energy is very important. Let us approach energy, since you have a very heterogeneous children from various schools. What is energy? We define energy as ability to do work. What type of work? Any type of work. Climbing staircase, be going for a mountain, playing football, riding a cycle, all these cases, you need energy. So ability to do work is what is the textbook definition of energy. Now, then you need to understand what is work. If energy is ability to do work, we must understand work. What type of work we are talking about? Any type of work. Work is energy transformed to or from an object. Suppose I have this phone with me, I take this. How much energy is needed? Energy is needed. If I have no energy, I will be lying like this. I cannot take this material. That is why we need to understand energy. Any work you have to do, you need energy. Simplest work is taking a small object, a book. What is the weight of the book? If you know, and from where it is taking, you can calculate. So we classify energy into various types. For example, suppose a crow is flying. Can you calculate, if you know the speed of at which a crow is flying, how much energy is there? So based on this, we can quantify energy. Smallest energy. Sometimes we need millijoules, sometimes nanojoules, extremely small amount of energy. A mosquito is sitting and hitting me. A mosquito is biting me. I want to kill it. How much energy I have spent? Mosquito is killed now. How do I calculate? I can calculate how much I have moved my hand. What is the force expended on the mosquito? If I know, I can calculate. Very small amount of energy. So we need to consider how much energy by using certain units. The simplest unit we talk about, joule. For example, if there is a bird of 1 kg flying with a velocity of 2 meters per second, 2 meters per second is very small. You can calculate, compared to your car or a plane or a plane. So if a bird is flying with 2 meters per second, I can calculate how much is energy. That is 2 joules. So work, energy, and power, all these are related. Power means rate at which work is done by a force. So joule is, we talk about joule per second, we call it as watt. Watt is important because with respect to that, we have different type of rating of power. So please remember, you have a 1 horsepower, 746 watts. So work, we may use work with various fractions. For example, in electrical energy, we talk about unit electricity. 1 kilowatt hour is 1 unit. 1 kilowatt hour is 3.6 into 10 power 6 joules. So please remember, joule is the elementary form of energy, the unit we consider. Now you can have megajoules, gigajoules. So we can talk about big energy, small energy. If you take a book and put it on a place, very small amount of energy only we consider, we can calculate. Compared to that, suppose you are going to rise a sumo wrestler. What is special about sumo wrestler? Sumo wrestler will have very huge weight. For example, sumo wrestlers will have 260 kg, 280 kg. So if I take a sumo wrestler in my hand, keep him 1 meter, put it up, he's down. How much energy I can calculate? If I height one meter height and I know the weight, I can calculate the energy by mgh. So how much energy is needed? Based on that, we have the concept of smaller energy, bigger energy. The energy is important for all type of activities. We get energy, we take it as granted energy is available, grid power, electric grid, there is a national grid, and there are certain grid, different forms of grid where electricity is mobilized and available. When you switch on, electricity comes. This type of power we call grid power. You have a distributed power, small energy, smaller quantum of energy. For example, if you want to make a cup of tea, how much energy is consumed, you can calculate. Take how much water heating from one temperature to other temperature, and you put milk, you put glucose. You can have different type of calculations. Please remember, all these forms of energy are important. Sometimes we need distributed power, sometimes we need grid power, but remember that without energy, life is not possible at all. So it is not surprising that as humanity evolved, I'm sure all of you know, our universe is, how old is our universe? Our universe is roughly is around 13.8 billion years old. How do we know? There are various ways. In fact, more than one way we can calculate the age of universe. So universe is 13.8 billion years old, but our science and technology, all our knowledge, everything is very small compared to the infinitely small, roughly around 2,000, 3,000 years old, all documented things. Science and technology with our present technologies maybe hardly hundreds of few hundred years old. Imagine after the Industrial Revolution. Please remember that energy was very important. Kings used to be there ruling us. They understood the importance of energy. They wanted to have elephants. Each elephant will give you at least few kilo beings with muscles. Muscles can give you 100 joule per second. And if you are an athlete running at a high speed, it can become 2 or 3 times more energy. So average human beings capable of 100 joules per second. If you are an athlete, it is 300 watt, and an elephant kilowatt. And then slaves. Slavery was invented because it is an easy way of stored energy, muscular power. I have got 10 slaves, I have got 200 slaves. This is where the kings used to boast. So actually it is a form of storing energy. And later we have got many other ways. It is also possible for you to calculate 1 liter petrol, how much energy can be served, and it is roughly equivalent to how many slaves. And now we have got nuclear reactors, so huge amount of energy. So please remember, our life critically depends on not only the availability of energy, but also the quality of energy. Clean energy, that is the reason why we talk about cleanliness of energy. Energy is important. Energy needs to be generated. At the same time, we don't want any untoward things happening on our environment. This is the problem because the conventional way of making energy, we have created so much of CO2. After the Industrial Revolution, so much of carbon dioxide is there around. And this is the primary source for global warming. The worst polluting countries, China, #1, US, #2, India, #3. These are all we are all looked up by global community. That's why we have got various programs to clean our environment. Energy density is an important term. One unit weight, for example, 1 kg of a material, if you use it, how much energy is coming out? That is what is called energy density, gravimetric energy density. So if I have got various sources of energy, I can compare which has got more energy by looking at energy density. Gravimetric and volumetric. Volumetric means 1 unit volume, 1 cubic meter or 1 liter, I take, how much energy comes out? So volumetric and gravimetric energy density is very important for us to understand or compare various sources of energy. For example, certain applications, you look at the extreme case, you have fast breeder reactors. These nuclear reactors can give you 10 power 10 watt-hour per kg, very huge amount of energy. Come down from fast breeder, you have what normal nuclear reactors, uranium fission can give you 10 power 10 power 10 power 8. Then you come down, you can see kilowatt-hour hydrogen energy. Our country has got a roadmap 2030. What are we going to do in the case of hydrogen? Hydrogen comes with the different colors: red hydrogen, blue hydrogen, green hydrogen. Green hydrogen is what we all want. So hydrogen economy, we call it as, because hydrogen economy is a concept where hydrogen is the vector of energy. Hydrogen is generated, hydrogen is stored, hydrogen is transmitted. Wherever you want electricity, there only you generate electricity from hydrogen. Wherever you want to do cooking, use hydrogen and cook there. It's an accurate control. When this economy where hydrogen is the currency of energy, that is called hydrogen economy. Right now, in some way, we can say we have a hydrocarbon economy because everybody uses diesel, petrol for mobility purposes. So that is the reason why we talk about hydrocarbon economy. So a transformation from hydrocarbon economy to hydrogen economy is imperative, very important, because that is one way of avoiding unnecessary climate changes. That is why there is so much of focus on that. So look at the energy density, 10 power 3, 10 power 2, hydrogen, coal, then comes batteries, fuel cells. I have been fortunate to work on this area: primary, secondary batteries, fuel cells, supercapacitors. These are all electrochemical energy storage devices, electrochemical power sources, we talk about it. So you can see now, energy density helps you to understand various sources of energy. For our life, we actually need very small amount of energy. For example, for wearable electronics, these days so much of focus on wearable electronics. You have a watch or you have something adapted with your textile, you have tiny circuits, small sensors embedded on the clothes. This is what is wearable electronics. Their energy level is very small, few milliwatt per square centimeter. Compared to that, you can see cell phones, your mobile phone, that sometimes you need 1 watt, couple of watts. Personal digital assistant, you need 10 watt, camera 50 watt, laptop 100 watt, power tools. Suppose you want to drill with a power tool, it needs 200 watt. So look at this, all these cases we need small amount of energy. So energy density we use for these applications is very tiny compared to what is needed for residential. You want to have a car, electric car, you will have 35 kilowatt hour, 20 kilowatt hour. Electric truck, you want 200 kilowatt hour. So look at this, very small energy for some applications. We need very tiny amount of energy and power. Here we need huge amount, and then sometimes you need UPS and utility systems, power storing, power shaving, total. There you will need several giga or maybe megawatt of energy. So all these cases, application is important. However, when we generate this in a large way, we have a lot of problems. What is happening in India? 50 years ago, if you go any part of our country, whether it is in Punjab or UP or Andhra Pradesh, you will see our lifestyle was agrarian lifestyle. That means you get up in the morning, have some food, go to the field, even pull a cart, or you will even see that even cooking, you use fuel coming from cow dung. So how much energy you need? Very small amount of energy. Maybe you would say that maybe 100, 200, 300, few hundreds of watts. That's what your power you needed. These people were all actually happy even then. You can see the problem is that this agrarian lifestyle, that means agriculture-based daily lifestyle, all on a sudden changed into technology, huge. So the problem is, as India develops, we have a huge population. We believe that right now 7.7 billion, all over the world become 9.7 by 2050. India has 1.37, it will become 1.6 by the same time. We also want to have a 5 trillion economy. And this lifestyle with very, what you call, minor amount of energy consumption becomes huge cities. So we see a transformation from village, or we would say that, some rural lifestyle, or a very small amount of rural lifestyle with minimum energy expenditure to a huge big city. For example, you can see this city, by looking at the traffic, you can all guess what is the city. It is our capital. We have 30 million people on 2022. And this is, people are still, the population is increasing. We'll have 36 billion by 2030. By that time, we will be #1 in population. Right now, Tokyo. So we are the second most popular city, but soon we will overtake Tokyo and we will be the #1. Of course, that needs a lot of energy for these traffic problems. Then you already know the air quality in Delhi is terrible. All these problems are there. Please remember, from an agrarian lifestyle, we catapult into this lifestyle. Not only in Delhi, look at Mumbai. 24 hours the city is active. City is growing vertically as well as horizontally. There is no limit for growth. So much of energy we need. 24 hours, shops are active. How do we provide minimum living standards, good water, good health? How do we provide? That needs more and more energy. That's the reason why our energy demands are skyrocketing. More and more cities, more and more flyovers. Please remember, this is not only happening in Mumbai and Delhi. Any other place you talk about, Chandigarh or Pune, everywhere you will see. Bangalore, Chennai, Kolkata, Pune. Pune has, interestingly, more vehicles than even people. Pune, urban Pune, we have 3.5 million people, but 3.62 million vehicles. I don't know about Chandigarh, but you can imagine. So there are problems, limits of growth, because when we want to generate energy for such development, we have several problems. We have so much of pollution. Global index is very poor. Look at all these power plants. They generate so much of CO2, NO2, SO2. No wonder that Copernicus spacecraft took a picture of our globe from outside. So there is a special camera, Sentinel-5P, launched by European Space Agency. And if you look at the image of Earth, our globe, see these all brown patches. These brown patches come because of nasty pollutants. India also is not in good at all. India also is almost like South Africa. I mean, not the African side where you see these dirty patches. It's all footprint of our gaseous pollutants, formaldehyde, nitrogen peroxide, ozone, sulfur dioxide, methane. All these are responsible for such a bad night. In addition to that, when we generate energy from fossil fuel, we generate so much of CO2. And CO2 is considered as a devilish enemy because global warming, primary culprit is CO2. And we also have many other problems, climate-related problems. Some side you have so much of flood. You go 100 kilometers, you have so much of drought. So this imbalance in the climate, primarily because the way we are managing energy is not right. This is why we show this globe with both Arctic and Antarctic as just burning. We have literally a lot of problems. Somewhere 1979, NASA image shows so much of glaciers. These glaciers, white-colored glaciers, they are sources of pure drinking water. Even in Himalayan region, we had around 273 such glaciers. That was in 1970s. Now the satellite picture shows that there is nothing. All these are disappearing at an alarming rate, partly because of our own activities. We speak about anthropogenic activities, human-created problems. I'm sure most of you know, Delhi, fog will come. December and January, there is very, very difficult even if you move post-Diwali era, partly because of crackers, partly because of all the pollution from power plant, burning of crop materials. See this. So sometimes Supreme Court generates gives a guideline that children should not be allowed to come out of the house. House is much better, partly because of particulate matter. So we see urban smoke as an enemy. Air quality index become 999. 300 itself is considered as hazardous, primarily because of small particles of carbon. That's why carbon is considered as an enemy. Traffic, that means transportation is one reason. Burning agricultural residues in neighboring states. So please remember, no, these are all the problems where we have to face. No wonder we focus more on renewable energy. Energy sources can be classified as energy sources from hell and energy sources from heaven. Hell means you go down, 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 down is supposed to be hell. That means hell will have fossil fuels, that means coal, natural gas, anything you take, that is all energy sources from hell. So we need to stop energy sources from hell and give more importance to energy sources from heaven. So energy sources from heaven essentially is renewable energy. We talk about wind and solar are major two sources of energy. Of course, there are minor sources, oceanic energy, small hydro. Big hydro is again a problem because they create problems for the environment. There are certain areas where you get geothermal, then you can generate energy from biomass. So these are all the sources of energy where we need to give more importance. Actually, thanks to science and technology and brilliant scientists from various countries in the world, they have come up with various solutions. Wind and solar. Look at these installations. Global wind and solar installations in gigawatt. Starting from 2000 onwards, you will see a huge increase in terms of solar and wind. Yellow indicates solar and wind is blue. So not only in India, the whole world is going for renewable. No matter what have the other implications. You will see the cost also keeps coming down. That's the reason why solar and wind is very popular in many places. However, many other places that the power plants are already there for 100 years, 200 years, you cannot stop immediately. So there should be a plan. That's the reason why intergovernment climate panels, IPCC, they come up with the solutions. India is also a signatory. We'll talk about it. China, being the worst polluting country, they have something more interesting. They have got huge air purifiers in big cities. You go to Shanghai, you go to Shanxi, all these places, Shanghai, you will see that there are towers as big as a 12-story flat, towers, huge towers. What this tower will do? It will suck air, dirty air from down and purify the air and send it down. So this type of air purifiers, huge columns, because China, I mentioned to you, China is the worst polluting country in terms of emission. 29% of global carbon emission comes from China. That is why they are important. So when all these world, all the governments come together, there is an agreement. When will you make energy carbon neutral? Carbon neutral means we generate energy without emitting any CO2. So every energy generation technology has its carbon footprint. Solar is something very good because it has got very least carbon footprint. Solar is renewable. However, of course, long term, if you think about it, there are problems. I mentioned to you that the universe is 13.8 billion years old. Our solar system is roughly 4.5 to 4.6 billion years old. That means sun is also more or less that time. Sun is like a middle-aged man. That means after some time, sun will not be there. So we have a limited time. If we can depend on sun exudes so much of energy. Even few hours of energy is enough for us to have all our requirements globally met. However, we cannot say sun will be there forever. Sun maybe another 5 billion years, after that or 6 billion years, then sun will disappear. So we have around 5 billion years to plan our escaping route. Maybe we will have very, very interesting solutions. We may have interplanetary travel. We may have maybe we will go to some other system. We have no idea about it. Maybe even intergalactic travel will be possible because so much of time is available. So these are all more towards imagination. But we have around 5 billion years. So sun will continue to give us energy for a long time. So solar, we have various ways of converting solar energy into light. Solar tiles, solar buildings, photovoltaic, photoelectrochemical. So please remember that solar and wind get so much of importance because of the renewable aspects. It is also important that we must have energy. We must have various energy conversion or energy generation tools where carbon footprint is minimum. We do not know after another 10 years, 20 years, government may put a carbon tax. Many other countries have already started carbon tax. That means clean energy will get some financial benefit. Look at the total emission. I mentioned in China generates 29%. After China comes US, then comes India. So India is looked up by many other countries as the third worst emitting in terms of CO2. China, US, India, Russia, Japan. However, if you divide by population, then we are much, much better. So this is the carbon emission, cumulative carbon emission. But if you divide by the population, since we have a huge population means our demand is also huge. We want to go, we want to have a development, we want to give minimum comfort to the huge population. That's why our demand, energy demand will skyrocket. India, Brazil 1.8, Brazil 2.5, France 5. France is more like a European country. China already has 7.6, Germany 9.3, Russia 12.4. You can imagine, see carbon emission, cumulative carbon emission per capita. All these are important because the environmental quality index is also influenced by the energy generation. India has a poor environmental quality index. We are around somewhere 150 to 160. You can look at India here. China is much better than India. And of course, these are all the green things are much better. Scandinavian countries, in US, you can imagine some of these are also bad. So environmental quality index is also important because it gives you some information about energy, how the generation of energy impacts the environment. So for us, what is important also is because we need to generate energy and store energy. So global energy storage is also very important. 2022 globally, it is increasing everywhere. But United States and Europe, the requirement, the development, the improvement is very small compared to India, Brazil, many other countries. So please remember, the environmental quality index is one parameter. Air quality index is slightly different. Air quality index in India is also not very good. Many places close to Delhi, you will see all red color, red color, red color. In where you can see a cartoon. This parrot is asking this parrot, hey parrot, how are you? How can you become black in color? And the parrot says, I just arrived from Delhi. So Delhi air quality is so poor. It is the cartoon is indirectly telling you that don't go to Delhi, you will get all this black color. Partly because of poor air quality. So we need to generate energy and we need to store energy. Energy storage, there are many technologies for energy storage, but we need to look at the impact on environmental quality. For example, you can have mechanical energy storage, pumped hydro energy storage. You can pump water pumped at a higher altitude and then allow it to fall down, a turbine, generate electricity, store energy. Compressed air energy storage, huge underground network where gases can be pressurized and put there and you can take it out. So flywheel, these are mechanical modes of storing energy. There is a method of storing energy, very convenient method is called electrochemical energy storage. Electrochemical means chemical reactions will happen and accordingly electricity can be generated. So you can store as chemicals. For example, you have got fuel cell. You can store energy as hydrogen. Whenever you want energy, allow hydrogen to react with oxygen and you will get energy with no environmental impact. Hydrogen and oxygen, they will react to form water and electricity. This is why electrochemical energy generation technologies are clean. Storage, of course, you can store them in the form of batteries, primary batteries, secondary batteries, different type of batteries. You have got lithium batteries, sodium batteries. They all store energy. The thing is, they store only a limited amount because huge amount become very, very expensive. So, electrochemical energy storage devices, we call it as electrochemical power sources. They could be classified into batteries, fuel cells, and supercapacitors. We'll talk about it within a few minutes. Please remember, you can also store them as chemicals. You can store them in various superconducting rings. You will put energy and it will be there. No loss at all. If you have good superconducting material, whatever you put can be there. You can collect it after 1 week, 1 month. No loss will be there because you have a superconducting rings in that. So there are various ways of storing energy, but some of them are very fast, some of them are very slow. Some of these techniques have self-discharge. Today you put 10,000 rupees, tomorrow you go, you get only 8,000 or 5,000, something is lost. This type of loss happens due to various reasons. We call them as self-discharge. So energy storage is very important. Various methods of energy storage are there. You can have stationary storage for renewable sources. You can store the energy. You can have mobile storage. You can use it for clean transportation. battery-powered auto rickshaw, battery-powered vehicle, fuel cell-powered car. You can have a solar energy stored there in batteries. So these are all various modes of energy storage. Our future depends on sustainability. What is sustainability? Sustainability means meet the demands of the current or the present time without compromising the future. For example, when you all grow 20 years, 30 years, if this environment is so bad, you will always blame us. That is why sustainability is important. Sustainability is a recurring theme. Sustainability says, meet the demands of the present time without compromising the future, without creating problems for the future generations. And that's the reason why all countries come together, make mandates. We will reduce carbon emission by 25% by this much time. We will make sure that we'll generate more energy only by renewable. So all the countries in the globe, they come together, they make some rules, guidelines, follow them, so that the future is bright. All this started with something called Kyoto Protocol. Some of the countries met in Japan, the place called Kyoto, made sure that they wanted to understand the problems, and now every year they meet. COP21, COP22. COP means Committee of Parties. Recently we had COP26 in UK. Our Prime Minister made a very strong statement in COP26, international commitment from Indian side. India is accused because we are the third biggest emitter of greenhouse gases. But we told that by 2070, we will do everything possible to become net zero carbon emission. That means we will generate a lot of energy, but by 2070, our energy generation will have no CO2 coming out. Right now it is there, but we cannot help. We have a huge population. We have so many places where we need to generate energy. We need to have living. We need to make airports, highways. That's why development is a double-edged weapon. If you don't develop, we go back to the forest and we don't generate any CO2, but that is not possible. That's why India, with a huge population, cannot overnight change it. US wants to be carbon neutral. That means energy generation with no carbon dioxide by 2050. China has 2060 and we are committing 2070. But on the other side, we are doing so many other things. We are telling that we will generate more and more renewable energy. Maybe I'm in a meeting. We'll talk to you later. Yeah, after 10 minutes or after half an hour. Okay. So what happened is, our Prime Minister made several announcements. 500 gigawatt non-fossil fuel cell power generation by 2030. It's a major announcement. A lot of work we need to do. We will meet 50% of energy coming from renewable by 2030. Reduce the carbon emission. We say we will make everything possible in such a way that 2070 will be carbon neutral. US 2050, China 2060, Saudi and EU 2050. You can imagine, everybody is trying this because we don't want global warming to above 1.5 degree. These are all projections. This type of plot is called death curve. Very interesting. 3 a.m. to 6 p.m. How the power demand changes. That plot. And this is true for everywhere in the world. How it changes with this. So important point is, we are having a comfortable life. We cannot go back to forest and live without creating problems. So there is a balance needed. How this balance is achieved depends on all of us. It is essentially for us to balance the energy generation, energy storage, bone-based energy, electricity generation is also very important, storing, transmission losses. So if you look at it in a balanced way, there are many interesting aspects and scientists must focus on this, making new materials. For example, you can use sunlight to generate water, to split water, generate hydrogen and oxygen. Scientists make different types of solar cells, solar photovoltaic, there are dye-sensitized solar cells, different type of polymers, polymeric solar cells. So new materials are important. All these cases, it depends on physics, chemistry, and engineering. Physics is very important because to understand the interactions, strong force, weak force, what type of interactions are needed, how many layers of materials, atom by atom, molecule by molecule. Chemistry is important to make this wonderful material. So we need chemistry, physics, biology, the integrated sciences to solve these problems. You can imagine, sun is the basis. We can look at it. Storage, conservation, conversion, all these are important. We need new materials which will give you high efficiency. For water splitting is very important. Imagine sunlight, water, and then you will be able to get all the needs by generating hydrogen. Right now, it is not economical. Most of the hydrogen, 90% of the hydrogen in the world, almost 85%, is made by steam reforming. Steam reforming is cheaper, but it generates CO2. We don't want, in future, we want everything coming from water electrolysis. At present, the hydrogen obtained by water electrolysis is 3 times more expensive than hydrogen obtained by steam reforming. That's the reason why we still want to make better catalysts, better, more efficient water splitting. What is going on in these areas? So please remember that hydrogen comes with the different colors. Green hydrogen is the true hydrogen coming from either solar or wind. Wind is also very important. Wind is actually again a part of solar. Solar, because there are temperature gradients and accordingly wind generation happens. So wind speed, minimum wind speed is needed for generating energy. So please remember, in hydrogen economy, India has a roadmap for hydrogen energy for next 20 years. We talk about various ways of hydrogen. Right now, our hydrogen is brown. Brown hydrogen means some hydrogen is coming out from coal. Gray hydrogen is hydrogen coming from natural gas. Blue means slightly better, but green is the ultimate because hydrogen comes with no environmental impact. So that is how the classification comes. Because again, you can look at it. Carbon to hydrogen ratio is an index of progress. Primitive people use wood, maximum amount of carbon, small amount of hydrogen. As we became better and better, we started using coal, and then we use petrol, and then natural gas, and finally we have hydrogen. So the civilization, if you look at it, the carbon hydrogen ratio will also indicate you how progressive the civilization is that. For example, at the same time, we also have another problem because India, we depend a lot on many other countries for importing this. A huge import bill we pay. Oil, 85% of the oil we get from outside. Coal, 24% we get from countries like Australia. Even natural gas, 53%. So this import bill is so huge that is draining our resources. If you have got hydrogen available, abundant in the country, this also will be a major incentive. Now, this is the reason why Prime Minister has put an ambitious program. By 2022, we will generate 175 gigawatt of renewable energy, and now it is changed to 450. I have no doubt that the way the country is moving forward, 450 gigawatt we will definitely achieve by 2030. Generation part, there is no issue. Issues are with storage. Storage has a lot of problems. For example, we don't have a big way of storing energy. Fuel cells, we still have issues about materials. Fuel cells are better than batteries because the carbon footprint is very small. Hydrogen, if hydrogen is coming out from solar or green hydrogen is used, then there is no carbon footprint at all for fuel cell. There are issues about materials. Maybe you will study in a larger classes. Issues related to fabrication, issues related to hydrogen generation, hydrogen storage, and the cost is very, very prohibitive. Fuel cells, batteries, and supercapacitors. All these three are good for storage of energy. However, supercapacitors are much better if you want pulsatile store of energy. Either you want to put energy at a very fast rate, or you want to take out energy at a fast rate. Supercapacitors are much better than batteries and fuel cells. We say that batteries and fuel cells will have high energy density, poor power density, while supercapacitors have high power density, very poor energy density. That is how you can, store so much of energy, but you have to also dissipate. Otherwise, you become very obese. You have a lot of health issues. So all these three, batteries, fuel cells, supercapacitors, are compared by using energy and power density, rate of putting energy and taking out energy, cycle life, self-discharge, and environmental impact. You will not go to the details, but please remember that we had several such wonderful systems even long ago. 6,000, 7,000 years ago, we had batteries. Agastya Maharshi has written in Sanskrit about Agastya Samhita, which talks about batteries. The only thing is, it was in Sanskrit, various terms were different. Mitra, Varuna, Pranavayu. You can see they have been making batteries 6,000, 7,000 years ago in India. Clean copper plate. They were also using separators, using sawdust. So this gives us, unfortunately, we lost all this information, but there is so much of evidence to show that 6,000, 7,000 years ago, ancient India, we were making batteries. For what purpose was not very clear, but electroplating was there. After that, Baghdad batteries 2,000 years ago, Sumerian civilization, they have huge batteries. Again, with the copper, iron, they use acetic acid, vinegar for electrolyte. All these indicate that they were there traditionally. In modern times, we have got wonderful batteries, lithium batteries, starting from copper, zinc, electron, lead acid batteries. I will not go to details. I only want to tell you that the modern lithium battery is an engineering marvel. So wonderful. You don't use lithium, but it gives you power like lithium. The explosive aspects of lithium are cleverly taken out by putting lithium ions in some carbon matrix. And then you have got different type of such materials. So anode, cathode, and lithium ion cycles between these two, shuttles between these two. So sometimes you call it as a shuttlecock battery. Some of you play shuttle badminton, you know. Similar way, lithium ion shuttles, people call it as shuttlecock battery or swing battery. Lithium swings between the anode and cathode. And one issue is that there are some electrolytes which may create explosive problems. So people are looking at solid state batteries. Remember, transportation is a major cause for carbon emission. So if we have got battery powered vehicles and fuel cell powered vehicles, then the pollution aspects and climate mitigation due to transportation we can overcome. That's the reason why everybody is looking at electric vehicle, battery powered vehicle, and fuel cell powered vehicle. Unfortunately, they are expensive, but things are changing. I'm sure within the next few years, you will see many of these things changing our lifestyle. CSIR had an ambitious fuel cell program. Several laboratories worked together. CSIR NCL, CSIR Sikri Karekudi, and CSIR NPL. 3 labs came together to make a fuel cell. So this created so much of energy. Polymer electrolyte fuel cell, various types of polymer electrolyte fuel cell, many prototypes have been made by these labs. Of course, various in the sense that some of them at room temperature, some of them at high temperature. They all work for 4,000, 5,000 hours. However, not very cost effective. Still, we need to have material innovation. Unless we have got cheaper materials, this will not be, we will not be able to commercialize. So still work is needed in this program. We also worked with industry. Reliance was a partner. APIT was another partner for transportation applications, and for stationary application, we made several fuel cell models. Let me try to conclude what I wanted to talk to you. Energy generation is very important for the progress of our country and our future. At the same time, CO2 is something which we need to, we need to solve. This carbon is not really an enemy. Many people consider carbon as an enemy, but for a scientist, carbon is not an enemy. We can transform carbon and enemy to a friend, because all the CO2 which comes out during energy generation, we can store them and we can convert them into useful products. Then we will have a method of converting enemy into a friend. That's the reason why CSIR focuses on such new projects. CSIR has a major program on CO2 conversion to various products. Chemists come up with unusual catalysts. Some of the catalysts you use, CO2 can become ethanol. CO2 can become ethanol. They are all like a fuel. Sometimes CO2 can be converted into carbon. That means carbon nanotubes, graphene. So imagine there is a limitless possibility of innovation. CO2, each power plant generates several tons of CO2 per day. These tons of CO2 can be captured, stored, and then you can use them. This is what is called CO2 sequestration. And if you do that, our energy generation technology will become negative carbon technology. Every energy technology has its carbon footprint. Positive carbon footprint means while you generate energy, so much of CO2 is coming out. That's why we don't want conventional coal plants, conventional power plants, because generating so much of CO2. Carbon neutral means energy is generated but no CO2. Carbon negative means energy is generated but CO2 is sucked up, removed from environment. That is why there's a greater focus on CO2 negative energy technologies. Carbon negative. Carbon neutral was there so now, but since so much of CO2 was already created by industrial revolution, many countries have already done, developed countries are all come up with so much of emission. We need to encourage more on CO2 negative. That is why carbon negative technologies. And there are several projects, global projects on conversion of CO2 into value-added material. So from emitting power plants, CO2 is taken, absorbed. In UK, there are several CO2 sequestration projects. Underground, the mines and seas, we have a huge area where CO2 is stored there. These are all important for the future. And in mobility, we have also electric vehicle that becomes all the more important. India, we have a major mobility mission. Government has come up with an electric mobility mission by taking 3-4 ministries together. There are incentives. They are going to make charging platforms in Mumbai, in Bangalore, in Delhi, Gurgaon, many places. You can go and put your vehicle and charge it, and next day morning you can take it. Or you can have a battery swapping. For example, you can see now Honda Clarity 2022, you will have a fuel cell, very expensive. So one of the problems limiting fuel cell powered vehicle is even now we use platinum. So it is quite expensive. Platinum is expensive, membrane is expensive, many other things are expensive. So you need to make them cheaper. Again, we need material innovation. For example, Honda has a Clarity fuel cell. Last 10 years, it is ready. Unfortunately, it's very expensive. Honda Clarity and many versions of such electric vehicles are available with fuel cell, not only with the Honda, but also with the Toyota. Toyota in the Mirai was very promising, but every year it is not becoming cheaper and cheaper in the way where people can buy it. But I'm sure that one day they all will replace the conventional IC engine powered vehicles. Efficiency is very poor, emission is a major problem. Compared to fuel cell powered car, battery powered vehicles are much better. They are much more realistic. India, for example, we have several such vehicles available. Companies like Tesla, then General Motors, then Toyota, they all have battery powered vehicles. And this area is so important because even machine learning is important because computers write books. The first book written by computer on any subject is in this area of lithium-ion batteries. You can imagine all these cars, this book called Lithium-Ion Batteries, written by a machine. The first book written by a machine in subject area. Earlier machines, computers have written books, poems, songs, novels, but subject book, this is the first one. It's really available. Of course, reading needs more and more knowledge in some areas. Similarly, we have got renewable energy shirts which will have a solar panel. It can take up sunlight, and there are small batteries. I mentioned the wearable batteries for generation of energy and storage of energy. And if it becomes very hot, there are small fans, so you can cool your body. Remember, we have a road for super battery for tomorrow. Many batteries are coming up with wonderful materials. I will not go to details. They are all more complicated how it functions, but these numbers are important. 250 watt-hour per kg. 1 kg can give you 250 watt-hour. 1 liter can give you 650 watt-hour. That is what is happening right now with many important materials: lithium manganese, lithium cobalt, lithium nickel, lithium iron phosphate, and different type of electrolyte. Future, we have got much better batteries. Everything will be solid state lithium batteries, at least double or triple energy density. We will see many companies, startups forming these type of batteries. Sometimes companies come together to form a consortium. Toyota, Nissan, Honda, Panasonic, they come together because each one company alone cannot do research. So expensive. Market is so complex. Tesla won't save so much of money. You are need to compete with them. That's why many companies come together. They are focused on solid state batteries. 2030 will have batteries capable of 800 kilometers range. Range is a problem because the energy is limited. You cannot go far away. And the cycle life, these are all important systems in the future. But future depends a lot on all solid state batteries. Cathode is a solid, anode is a solid, electrolyte is a solid, separate is a solid, and they are all layer by layer. You can make using 3D printing, new technologies, technological disruptions. That is what is happening in the area of energy. Energy landscape is very dynamic. Every day it changes. The other day we are having even windmills which can be floating windmills in sea. You can have some small windmills, just put it in the space. So the technology, what we see today will not be there tomorrow. Everything changes. This disruption happens because knowledge advances exponentially. Physics, chemistry, engineering, all that will converge. Nanotechnology is one example. Whatever we have studied in physics, chemistry, biology, etc., in conventional, some of this can just change by a flick of your computer, the time scale. You will see many things changing, different type of materials. So I'm sure that you will see the disruption in energy landscape will continue. We'll have much better environmental footprint without generating CO2. You will have new type of batteries. Lithium, there are a lot of problems with lithium availability. So people come up with the sodium batteries, magnesium batteries. They all are coming up. Some of them will be important only for small scale applications, mainly what? Wearable electronics. Some of them, such as lithium sulfur, sodium sulfur, redox flow battery, etc., are important for kilowatt to megawatt energy storage. And you will see interesting materials, flexible, bendable batteries, fuel cells without platinum. These are all developments. All this needs the young minds to come and work in this area. That's the reason why we would like to inform all school children. These are all the opportunities available. We need people to think outside our standard box. I would like to conclude this lecture by making a statement from Richard B. Feynman. I'm sure all of you know about Richard B. Feynman, a famous physicist, Nobel laureate who also loved chemistry. He was also a very, very innovative thinker. We are at the very beginning of a time for the human race. It is not unreasonable that we grapple with problems. The problems will be there, but there are tens of thousands of years in the future. Our responsibility is to do what we can learn, what we can improve the solutions and pass them on to the next generations. So I'll just summarize. I've been talking to you about the energy landscape in the country and also globally, comparing where India is right now and where we are trying to move. And there are plenty of opportunities for innovation and research, whether it is solar or wind or batteries or fuel cells. Materials is the key. Generate affordable materials, cheaper materials, lighter materials, materials with higher energy density, much more robust materials. That is where we need more and more talented children to come and work on these focus areas. I'm sure programs like this, what CSIR has arranged, will create a spark on some of you. Some of you will have an obsession with generating much more cleaner environment for the future of all of us. That's the reason why even somebody came up with a carbon dioxide battery. Idea is interesting. You can make a sodium carbon dioxide battery. Sodium Na plus is one. CO2 become carbonate is another one. But most of these cases, reachability is very, very poor. But ideas are not limiting. You can have any type of idea. So it is in our hands. I'm sure that many of you will get motivated to understand the problems, and becoming a scientist is one way of solving global problems. Scientists belong to everybody in the world, not only one country. That's the reason why, as global citizens, I request all of you to think about these problems, work in this area. I'm sure some of you will be able to contribute to solve global issues which are grappling the entire humanity. Because energy is number one problem for everybody. With this, let me thank all of you for your patience. And any questions you have, please type on the chat box. I have no other commitment. I can spend as much time to discuss with you. Thank you all. Hello, Dr. Pooja.
Yes, sir. Thank you very much, sir.
Yeah,
Isha, please take over. Yeah.
Lot of chat boxes. Will you be able to read one by one, or?
Yes, sir. We'll coordinate it. Yes.
Yeah, that is nice. Because some of them will be same questions, right?
Yes, yes. Sir.
Thank you, Professor Vijay Mohan Kepelai, for sharing your knowledge with the school students and also highlighting the importance of using the energy sources from the heaven. Thank you so much, sir, for your informative lecture. Now, first of all, I would like to call Professor S. Anantha, Director, CSIR, CSIO, for giving his remarks. Sir. Sir. Sir, am I audible?
Sir might be joining in another meeting, so probably sir may not be available.
Okay, ma'am.
Yeah. So maybe on behalf of sir, I would like to thank Professor Vijay Mohan for a very informative session. He covered a wide span starting from the energy generation to the storage and to how we can make our enemy like that carbon dioxide into very useful things. So very nicely and in a very simple way, sir, you delivered this lecture, and I hope all the students will get benefited from this session. And the way you have delivered, we can see there are a lot of questions which have come up in the chat box from the students. So I would now request Isha to coordinate this interaction session.
Yes, ma'am. So I would like to invite Aminul Islam, one of the team member Jigyasa, to take up the questions from the students and continue the program ahead. Aminul, over to you.
Thank you, Isha ma'am. So myself Aminul Islam, one of the project associate under Jigyasa program, and I would like to continue with the question answer session. And for that, I'd like to share my screen. And Sir Vijay Mohan sir, can you stop sharing your screen so that okay, thank you, sir. Thank you, sir, for your wonderful space and wonderful content for sharing with us. And I'd like to share my screen for the question answer session.
Aminul, you first have to take the question which are there in the chat box.
Okay. I have taken already
so
far.
Fine.
Okay. Yeah. So from webinar and YouTube, I have collected some questions. One question from actually my screen is visible, I hope.
Yes, please go ahead.
Okay. One question from Mr. Ansh Yadav. So first question is, did energy wants any medium for traveling? This is the questions. So if
Pillai, sir?
Sir, here is the question. First question is from Mr. Ansh Yadav. So did energy wants any medium for traveling? He asked.
Sir is not in the panel. Aminul, can you check? Somehow I think yeah.
Yes.
Oh, sir is in the attendee. Can you upgrade him into the panelist?
Akhilesh?
Yes. Yeah. Now I can see. Yeah.
Okay.
Yeah.
So you, yes,
sir,
thank you.
Sir, I'm sharing some questions that I have collected from webinar and as well as YouTube chat box.
Yeah,
so I'll share.
Let me first unshare my screen. Otherwise, I will not be able to see.
Okay. Your screen is unshared already, I think.
Oh, is it unshared already?
Yes, sir. So you can see my screen, sir.
Yes.
Okay. The first question is for Mr. Ansh Yadav. So he's asked the first question: did energy wants any medium for traveling?
No. Energy doesn't need any medium for traveling. Energy can go through vacuum. Our understanding of vacuum is changing dramatically. Hello?
Okay, sir.
Yeah. So short question is no. Energy doesn't need any medium for traveling. In vacuum itself, otherwise light can travel. Light is a form of energy, right? So easy to ask yourself the question, why do you need a medium?
Oh. Okay, sir. So next question is, can momentum be hidden to the eyes of to the human eyes? Like how kinetic energy can be hidden as hit in the human body, like that. This is the second question. Sir.
Okay. One question: can momentum be hidden to human eyes, like how kinetic energy can be hidden as heat? See, I don't know what is the meaning of human eyes. Is a perception subject-wise. Suppose a blind person. So the momentum is an external thing. Some body is moving. Mass into velocity is momentum. Now, if you are seeing a small toy car moving, car is moving is a momentum. Hidden by human eyes, the question is not clear. You close your eyes, you won't see anything. So kinetic energy can be hidden as heat. Kinetic energy is not hidden as heat. Kinetic energy is molecular motion. So molecules are moving. So sometimes the movement is so fast, heat is increasing. So heat is a form of expression of the kinetic energy. Kinetic energy, how fast it collides. That's why the question needs to be a little more clear. Human eye is a personal, my eyes, your eyes is like a personal, while kinetic energy is a very generic term. I hope I answered the question.
Okay, sir. So next question is, does hydel energy have more power to light up a bulb of every house in India?
No. Hydel energy is only location specific. You go to certain part of sea where waves move at very high speed, you will get. But you have to store it in somewhere, take it out. That's why hydro energy can be good only in some small places. It is highly location specific.
Okay, sir. Thank you. So next, another person.
Answer is no. Every house cannot be used. Our
Okay,
house,
sir.
our people population is so high that you cannot use it. Yeah. Next.
Next question from Mr. Raghav Chaudhary. So, like, he was interested in asking if energy neither be created nor destroyed, then why do you need to conserve it or talk about it like that?
It is a very, very interesting question, very nice question, because if energy cannot be created and not destroyed, why do we talk about conservation of energy crisis? So energy crisis, energy conservation, these are relative terms. The quality of energy varies with that. Energy can neither be created nor destroyed, but energy can be transferred from one form to another form. During this transformation, an entropy part. Entropy is more a form of disorder. So when you say more and more heat is generated, more and more disorder is formed, so we need to look at the system and the surroundings. What happens in the environment? That is exactly what we talk about surroundings. So the question is that although energy cannot be created, neither created nor destroyed, the quality of that energy changes every time you transform from one form to other form. So something bad happens to the environment, entropy keeps on increasing. That is why we need to conserve it. I hope it is clear.
Yes,
So
sir.
the quality of this energy, when you say energy is neither created nor destroyed, we are not talking about the quality of the energy. It is something which is our experience based on every day. Energy conservation is like a den is the menace. You know, you have some 20 blocks, one day one block, you don't find it. So you later find out that is in the other room, and you say that it cannot be neither created nor destroyed. But the quality aspects are not coming into picture. I hope that helps.
Thank you, sir. So another question from Mr. Gagan. Is it possible to satisfy, this is the question, is it possible to satisfy the energy requirements for a country with a large population like India by just using renewable energy resource at the minimal cost?
I think, Gagan, your answer is there already in the question. I mentioned about it. Large population, we are talking about, 1.7 billion people, and also minimal cost. It is not possible. That is the reason why Niti Aayog envisages a future where coal will be important even after 2030 and 2040. So practically, we need to look at solutions. We will have to have fossil fuel with us another 20-30 years. But eventually, we will have clean, renewable energy. Minimal cost, then large population, these are all qualitative factors. At some stage, renewable energy will be there available. So we will have maybe, our environment will allow us not to use this after some time. So your question is very important question. It's not possible to have only renewable for a huge country like India with a minimal cost. But over a period of time, slowly we can shift. Good question.
Thank you, sir. And next question from Mr. Surya.
Shaurya Sagar, right?
Surya Sagar.
Yeah.
How do you strike a atom for producing nuclear energy?
Yeah, Shaurya, it is a very simple question, How do you strike an atom? How do you take a uranium-235 atom, huge atom, very, very unstable atom. You allow hit it with a alpha particle, hit it with a neutron, bombard with any fast-moving projectile, there is fission. So at many heavy atoms, if you strike heavy atoms, neutron-proton ratio will make the atom nuclear unstable. So hit with a neutron, hit with alpha particle, you can create fission. So these are all traditional technologies. But nuclear energy also has a lot of what you call it as adverse effects. We do not have a complete solution for storing nuclear radioactive waste. That is the reason why many advanced countries slowly come out of nuclear. But again, for India, like a huge country, maybe nuclear is for some time it will be needed. Sir, why are focusing on changing lithium-ion batteries to aluminum batteries? Do they have any specific benefits? Oh, yes. Aluminium, what is the most abundant material? You talk oxygen, then silicon, then aluminium, iron. So aluminium is abundant. While lithium, we don't have lithium at all. Lithium is available only in some lithium belt, Argentina, Chile, Bolivia. They are geopolitically unstable. China has leased all these lithium mines for next 300 years. So scarcity of lithium is a major problem. That's the reason why we are moving to sodium-ion batteries. Sodium-ion, then magnesium, aluminium. These are all not as good as lithium in terms of energy density and power density, but in terms of availability, they are good. So aluminium is one of the promising systems because aluminium is available, but aluminium has problems.
Okay. Sir, another question from
if the sun has used half of its hydrogen reserve, yeah, I mentioned about it. Does it mean that it has completed half? Yes. Sun, people can calculate what would be the sun because we know when sun will become a black hole. There are models available for us to calculate when sun will completely extinguish. At the rate at which nuclear reactions are happening in sun, if you know the kinetics of these reactions, Chandrasekhar limit, people have done, even you can apply statistical mechanics calculation. But we know that sun has almost 6 billion years ago it formed. Another 3-4 billion years it will be there. 3-4 billion years means how many human generations? So that's why we don't worry about it.
Okay, sir. There is another question from this one. Sir, when object is kept on some height, then it has some potential energy MGS,
Right.
and energy definition said him F into S. And my question is, the object have no acting force and no displacement, but it have some height. Then a definition of energy said 0, but potential energy said it have some energy. Please define it, sir.
So the question is, something is lying at rest. It has some potential energy with respect to where it is. For example, we are all on Earth, so we need to consider G. As long as it is lying there, we don't have any problem. But when it falls, it has an energy. That's why we define it as mgh. So G is there, M is there, H is the one which is important. If it is a relative parameter where it is falling, for example, suppose you are falling from bed to ground, you are already on the bed, you have some amount of potential energy, you fall, you fell down with some height. So there is a change in this energy. That is what is mgh. So the acting a force, as long as there is no force, it is there. It is relatively speaking, it is there in a particular energy level. But when it falls to from bed to you have a ground. Ground has a lower energy. Now from ground you can come out and fall still lower. So relative height parameter, which will tell you about how much energy is there stored in that. So the stored energy in potential energy is stored. When it starts falling, then it becomes converting into kinetic energy. That's why as long as there is no force on it, we don't talk about, but it has an energy stored in that material. The moment it falls, the kinetic energy will be important. I hope that is clear. So the height parameter is the one which is important for defining the energy. It cannot have a zero potential energy. I hope that is clear.
Thank you, sir. So another questions, last 3 questions. As the sun is the ultimate source of energy on Earth, why can't we make complete use of it? So this is the questions.
Because you imagine sun is so huge and we make so small. Sun radiates everywhere. If you can have a shield surrounding sun to absorb all the energy, we can only think about thought experiments. We can only store very, very small fraction, because even if, at this, you can see what is the outflux of sun, how much is it falls on Earth, and then only in the daytime, people have done rough calculations. So it is not possible, and people are thinking about creating a shield, Whenever we send a satellite, we use much more energy conversion of solar, because satellites go much closer. So it is not possible, although sun is the ultimate source of energy, we cannot make complete use of it, because daytime only what comes out and what comes inside. See, you look at our Earth, you look at the countries which are falling on the in the equator, those will have much more sunlight. So wherever there is large amount of sunlight, we try to store them. But there are regions where sunlight doesn't reach or sunlight goes away. How do we store them? That's why it is difficult for us to completely utilize the sunlight falling on Earth. Okay.
Thank you, sir. And last two questions. This one, sir, if energy can be renewed in all terms like light, mechanical, kinetic energy, etc., then why do we run out of energy so quickly?
We run out of energy quickly. We don't run out of energy. Again, this is related to the first question. The quality of energy is very important. Free energy. You can have energy, but that energy is not useful. That type of energy cannot be consumed at all. As you generate more and more energy, what happens? CO2 is also coming out. That's also a form which can be converted into energy. Some form of energy which was created under, imagine how petrol was formed. Billions of years ago, it was formed. Now we use it all, burn it within short time scale. As a result of that, many side products are generated and they are harmful. Conversion of mechanical, kinetic, this is only one aspect of energy conversion. There are forms of energy. Whenever you convert this energy, something is lost. That is what is the quality parameter. So when you study thermodynamics, you will learn more on this, what is called entropy. Entropy keeps on accumulating. People have been talking about entropy, death of the entire universe also. Every time you convert X into Y, imagine hydrogen plus oxygen giving water. Hydrogen, although there is a law of conservation of mass, where every time you take one mole, another mole, and it is generated, there is also heat created. So when you look at the thermodynamics completely, the quality factor also comes into picture. That is why mechanical, etc. are different forms of energy. Kinetic energy, yes. Thermal, mechanical essentially means, some physical movement. Every time you convert mechanically, the efficiency parameter is very important. So mechanical energy transformations, the efficiency is only 40–30%. That means remaining is waste. So please remember, whenever you have energy conversion, in thermodynamics, there is something called Carnot theorem, Carnot law. You allow gas will be compressed, then you allow a piston to release it out. That is what happens in a car. So in a car, what happens? The efficiency is limited by some parameter called the Carnot theorem. Efficiency is not very high. In electrochemical energy conversion, efficiency is very high. So each of these energy conversion technologies will also have their efficiency parameter. That means something is lost to the environment. That is how the inefficiency come into picture. So energy transformation technologies, we need to look at the efficiency parameter also. That's why one energy is converted into another energy. Efficiency losses are so important. Electricity is produced in a hydroelectric project in one place. You have overhead wires, you transmit electricity from a site where it is generated to a big city where you use it. Sometimes 30%, 40% is wasted for this transmission. That is why when you talk about energy transformation, you need to think it along with the efficiency parameter. Transmission losses are very important. That's the reason why we want hydrogen economy. Hydrogen economy, there is no loss at all. Most of the hydrogen can be compressed, and when you come to after 3,000 kilometers, you can always convert it into heat or chemical energy without much loss. So electricity transmission, major problem is transmission losses. So mechanical modes, again, there will be, rotating cylinders will have some amount of wastage, heat generation. That's the reason why the efficiency of each of these energy transformation technologies, we need to look at the energy efficiency part. I see some more questions. Somebody is telling we left his question. Varaprasad Sudha. So what is Varaprasad Sudha's question? Somebody, Kathy also telling he, sir, you left my question. Hello? You are muted.
So sorry, sir. Yes, sir. Some questions are recently posted. So
Yeah.
So last question posted sir, can't we biomodify the moss plant in such way that they could have a green a gene that can secrete a chemical like luciferin, so we can reduce electrical energy consumption only after the nocturnal activities of animal are considered. So, okay, I'm sharing this like in code file.
There are, genetic engineering is important because if you do genetic modification, some of these microbes can generate oil, hydrogen, etc. So it is possible that you can now have some genetic modification to create more such bacteria, which are much more energy producing.
Like one question is, can you improve the quality of energy with the help of science? Like this?
Yes, that is what we are trying. We minimize efficiency. I couple with a battery and supercapacitor, my overall energy efficiency is very high. So science will help me to waste energy, transmission losses. There are these days many ways to minimize transmission losses. So science will always help you to improve the quality of energy.
Okay, thank you, sir. As we have
another question: how much energy would be for 5 cheetah, lion, tiger? Calculate. I mentioned to you. Elephant can give you kilowatt. You put tiger a little lower. If you know the mass of the tiger, you will calculate what is the speed which cheetah moves. So mass is known, velocity is known, kinetic energy you can calculate half mv square and find out how much it is. All these things you can do. Do we need energy while doing work? Of course, yes. Do we need energy while sleeping also? Yes. Your sleeping means what? Your brain is active, right? So while you are sleeping, heart is beating. So you need energy. Everything you need energy. Mechanism of carbon capture. That is a complex question. Carbon capture means actually CO2 absorption. There are chemical ways of absorbing CO2. Carbon nanotubes can absorb CO2. Amines can absorb CO2. So there are several modes where CO2 can be captured and sometimes it can be converted into more useful products. So CO2 capture mechanism varies with respect to materials. There are metal organic complexes, metal organic frameworks which will absorb CO2. There are amines which will absorb CO2. What type of energy can use for others does not cause any harm to environment. So we suggest 7. You can't give it 7 energy names. Fuel cell will always store energy without any CO2 emission. Then if you are thinking about many other modes of hydrogen energy, for a certain microbes will convert CO2 into, just like photosynthesis, artificial photosynthesis. So there are several ways. So I don't know why they say you mentioned 7. Can the energy stored in battery be used anytime? Of course, yes. Night you can use, daytime you can use. If the battery is completely discharged, then you cannot use it. So as long as the battery is charged, we call it as technically state of charge. So if battery has a high state of charge, you can use it. But I believe the energy of sun can be used to great extent with the help of technology. Yes, I mentioned about this. It is only so that energy that falls on Earth can only be used. No, you have satellites which will go close to upper atmosphere and it can convert.
Thank you so much, sir. Actually, we have some time limitations, so we have to proceed further. So, thank you so much, sir. Thank you so much for answering.
Okay, Isha, I think you can give my email. If they have important questions, they can ask to me, send to me by email.
Okay, sir.
Some of the questions are very trivial, Some of the questions are very trivial. What type of energy did South Korean people? South Korean people have different forms of energy. South Korea, there is a windmill. South Korea has a hydrogen platform, small island, South Korea. So they also have strong fuel cell program. That's why questions need to be focused. South Korea, there are several energy related programs. There are actually some of them are pioneer in batteries. South Korea has Samsung.
Yes, so I think a lot of questions are pouring up. So we will share your mail ID with the students.
You can ask them.
Yeah.
What you can do is you can compile all this and send me an attachment to email. I'll write one.
Sure, sir. So I think after listening to your lectures and this interesting session, student would be very excited to take the quiz also. So you want to stay with us during the quiz time?
Maybe I will have to go. Okay.
Okay, sir. No problem, sir.
I also have 2 classes tomorrow.
Okay, sir.
I have a lecture. So
okay.
I need to prepare for that in the evening. Another 2 lectures are there on tomorrow. these things.
Okay, sir. Thank you so much, sir, for your valuable time. And I see the passion and the energy you have. And yeah, it's really great listening to you, sir.
Okay.
Yes, sir. Thank you so much, sir.
Thank you, Dr.
Thank you
Pooja.
so much.
And Isha Goel.
Thank you so much.
Aminul Islam. Okay.
Yes.
I will log off now.
Yes, sir.
Yes.
Thank you, sir. So, Isha, you can, Aminul, you